Today we're building to doing proofs by induction. And so this is the first video. I'm not sure how many I'll do, but I like to start this topic with deriving some of the summation formulas that that can be very helpful. Okay, so for example, what this chart is leading us through, we want the sum of n terms. Well, if it's as I goes from 1 to n of I, then it's 1 plus 2 plus 3, and so forth, up to the last term would be n. So when we start filling out this chart, our nth term, well, when n is 1, is 1, 2, 3, 4, 5, 6, and then our nth term. And then when we want the sum, well, the sum of just one term is just 1. The sum of two terms, so this would be s sub 2, is these two added together. The s sub 3, that means these three added together, we're up to 6. Basically, we took this last one and added that. Now we're up to 10, and we have 15, and then we have 21. So if you want to verify, we've got 7, and 7 times 3, 7 times 3 is 21. So then what they're leading you to, and this chart was done deliberately, okay, to get you to see what the formula is in a unique way. So when I double those, then they want us to look at the factors. Well, I know where I'm going with this. So this would be 2 times 3, this is 3 times 4, this is 4 times 5, this is 5 times 6, this is 6 times 7, and sure enough, this is 1 times 2. And so what I notice is that each one of them, this first number on each one of these terms is n, and then the next part is n plus 1. What I should have done is I should have asked you to pause it and try it yourself before I gave you the answer. But if you don't see what's happening here, what the formula is, then pause it now. Okay, so this is n times n plus 1. And this is, in conclusion, the sum as I goes from 1 to n of I, it's n times n plus 1. But this was 2 times the sum. This is not done. And so what we wanted is we just wanted the sum, so we have to come through here and divide by 2. And so in conclusion, the sum as I goes from 1 to n of I is n times n plus 1. This is arithmetic, and we know it's, do I want to talk about that? Yeah, I mean, this is how we typically see the formula, but if you think about an arithmetic formula, the sum of n terms in an arithmetic formula, it's the number of terms divided by 2 plus the first term times the first term plus the last term. Well, okay, so this is n over 2 times the first term was 1, the last term was n. And the way that we have written this is n times n plus 1 all over 2, which came from right here. So since it's arithmetic, it works out nicely. The next one that they're asking us to do is when we have the sum of squares. So plug in 1, I get 1 squared is 4, excuse me, 1 squared is 1. I was jumping to the next answer, my bad. 2 squared is 4, plug in that when I equals 3, 3 squared is 9, 16, and we're going all the way up to n squared. You may notice, hopefully, that this is neither arithmetic nor geometric, so we really do need to use this pattern here. So the first term is 1, 4, 9, 16, 25, 36. Our nth term is n squared. The sum is 1, and then we add these two, we're at 5. Add 9 more, we're at 14. Add 16 more, we're at 30. I'm at 55. Oh dear. Okay, 80 plus 6. 85 plus 6 is 91. Can I add? That would be 80. Yeah, okay. And then I need to multiply them by 6. Super. So 6 and 30 and oh dear, 60 plus 24, 84, and then multiply that by 6, 180. I'm too lazy. Well, and also I printed out my answer key. Okay, so pause just a second, pause the video, see if you can come up with the factors here, and then they do give us a hint to consider. So on this one, if I think about with this, yeah, pause here. See if you can come up with this row. Okay, unpause. So if I have this is 2n plus 1, well, in this case, if n is 1, this becomes 3. Well, I have 1 times 2 times 3, which, okay. On this one, when I have 2, this is 4, so 5, this is 5 times well, this is 2 times 3 times 5. Well, and if I want to multiply, okay, plug in 3, that's 7. 7 times 12 would give me that value, so 3 times 4 times 7. And this one, okay, so if I consider this, 8 plus 9, so 9 times 20, so it's 4 times 5 is 28 times 9. Do you see the pattern? I have n, and then 1 more than n, and then 2n plus 1. So n, 1 more than n, 2n plus 1, n, 1 more than n. And so this is n times n plus 1 times 2n plus 1. But this was 6 times the size, so I have to divide this by 6. So I've got n times n plus 1 times 2n plus 1 all over 6. Oh, my bad. So there is that the first page of the summation formulas. Practice. And then when we got here, let me talk through some of these. The sum of, if c is a constant, if I have n, well, so the first one, it's c. The next one is c. The next one is c. And I keep going until the last time I just have c. But there's a total of n of these. I can't spell. Whatever. I don't know. Okay, there's n of those. So this would just be equal to n times c. So if I have the sum as I goes from 1 to n of a constant, it's just the number of times that constant, or Cn. I don't remember what I wrote on my answer key. I said Cn, NC, Cn, whatever. On this one, we can say, what we can do with this is we can factor out and say it's the sum, C times the sum as I goes from 1 to n of a sub I. And so it might be helpful for us to find the sum of a sequence and then get that sum multiplied by the constant. Was that all I was trying to? Yes. And then on this one, what we're looking at here is that we are allowed to use, to kind of break this into pieces. It's a sub I plus the sum as I goes from 1 to n of b sub I. So we could add them together and then take the sum, or you could take the sum of this part and then sum of that part. And this is going to be really helpful as we keep going, and likewise with subtraction. So a few of these properties, we found this one from the first page, we found this one. These others are really great, but they're a little bit more involved, so I'm going to go ahead and give them to you. And this is posted and scanned. So, oh, don't look here. Okay, so we've got those two that we just found. These, they definitely get a little more involved. You have to know to multiply by 4, and then, but these formulas are given to you. And so then what I am asking us to do is to use those formulas right here. So if they were to say the sum as n goes from 1 to 10 of n cubed, well, that n cubed formula, I just forgot it, n squared times n plus 1 squared over 4. So the sum as I goes from 1 to n of I cubed is n squared times n plus 1 squared over 4. So since n here is 10, this would be equal to 10 squared times 10 plus 1 squared all over 4. That's 100, that's 121 divided by, okay, so, well, 100 divided by 4 is 25. I like to think in terms of quarters. And I'd go figure out what that is when I multiply. Or I would look at my answer sheet anyway. So, yeah, there you go. And then on this one, we need to use this formula, which I didn't write down, and it's rather involved. But if you look here, we're taking, this is I is going from 1 to 5. So rather than multiply, I mean, it might actually be easier to put the 1 plus what's 2 to the 4th would be 16 plus 3 to the 4th is 81. Maybe, I don't know, maybe that's easier to do by hand, but if this were a lot bigger than 5 terms, that would be a beating. So we're going to have 5 n for n, and then when we do that, we plug in 5 for n, we end up getting this, and it cleans up like that. Okay, so that's this, the properties of sums. Hopefully that made sense, and then we're going to talk about induction in the next video.